Assalamualaikum warahmatullahi wabarakatuh. My name is Mohd Izarif bin Mohd Ishak, and today I'll be presenting my mathematical reasoning assignment. In this project, I applied Polya's problem-solving model to a real-life situation, that is, to calculate the volume and water capacity of a combined cylinder and hemisphere water tank. So, a little introduction. Mathematics is not only about numbers and formulas, but also about understanding and solving real problems. That's why I use Polya's model, which has 4 steps: understand the problem, devise a plan, carry out the plan, and look back. Each step helped me think logically, plan my work, and check whether my solution made sense. So, for the question, local school plans to install a cylindrical water tank with a hemispherical dome on top to collect rainwater. The cylindrical part has a radius of 3 meters and a height of 6 meters, while the dome has the same radius. Students are required to calculate the total volume of tank in liters, determine the time needed to completely fill it when the water flows at a rate of 200 liters per minute, and analyze how much water remains after 30% of it used in one day. Finally, they should illustrate the structure of the tank and justify their calculation using appropriate formulas and mathematical reasoning. Alright, so now let's solve the problem. Step 1, we need to understand the problem. The problem describes a school water tank made of 2 parts, a cylindrical base and a hemispherical dome on top. The radius of both parts is 3 meters and the cylinder height is 6 meters. I needed to find 3 things, that is, the total volume of the tank in liters, the time needed to fill the tank when water flows in at 200 liters per minute, and finally the remaining water after 30% use in one day. Step 2, we need to devise a plan. To solve this, I use this method, which finds volume by integrating circular cross-section. My plan was simple. First, find the volume of the cylinder, then find the volume of hemisphere, and add both volume to get the total, convert it into liters, and then calculate the time and remaining water. Step 3, carry out the plan. First, we need to find the volume of the cylindrical part. So as I said before, we need to use this method in this part. So we need to integrate pi r square dx, and the limit will be 0, and the height of the cylinder, that is 6 meters. And since the radius is 3 meters, we can substitute it, and after substituting, we can get that we need to integrate 9 pi dx, and the limit will be 0 to 6. And after integrating, we can get that volume of the cylinder is 54 pi meter cube. Next, we need to find the volume of the hemispherical dome. To find the volume of the hemisphere, we need to integrate pi in bracket r square minus x square dx, and the limit will be 0, and the radius of the hemisphere, that is 3 meters. So after substituting, we get that we need to integrate pi in bracket 9 minus x square dx, and the limit will be 0 to 3. Since the pi is just a constant, we can put it out. So we can get that the volume of the hemisphere is 18 pi meter cube. After that, we need to find the total volume of the tank. And to get the total volume, we need to add the volume of the cylinder and volume of the hemisphere. So we get that total volume of the tank is 72 pi meter cube. But we want the answers in liters, so we need to convert it. Since 1 meter cube equals to 1000 liters, so the total volume is 72 pi times 1000. So the answer will be 226,195 liters. After that, we need to determine the time to fill the tank. Given that water flows into the tank at 200 liters per minute, so the time needed to fill it, we can use the formula time equal to volume over rate. So we can just divide 226,195 liters over 200 liters per minute, and the answer will be 1130.975 minutes. And the answer we want is in hours, so we need to convert it, and after converting we can get the answers will be 18 hours and 51 minutes. Lastly, we need to calculate the water remaining after 30% of it has been used. If 30% of the total volume is used in one day, the remaining water will be 70% of the original total volume. The remaining volume will be 0.7 times 226,195 liters, and the answer will be 158,336.5 liters. Therefore, the remaining water after 30% of it has been used will be 158,336 liters of water. After completing all of the calculation, I move to the final step of Polya's model, which is looking back. In this step, I reviewed every formula, double-checked the steps, and made sure the units were consistent, like converting cubic meters to liters correctly. I also compared my result with real-life logic. For example, a total volume of around 226,000 liters made sense for a school water tank of that size. If the number had been extremely high or even extremely low, it would have shown that I made a calculation error. This step helped me realize how important it is not just to find an answer, but to understand whether the answer is reasonable. It trains us to think critically and not to depend entirely on calculators. Overall, I learned that reviewing and reflecting on the process is just as valuable as getting the final answer, and it's what truly strengthened mathematical reasoning. In conclusion, this project has taught me much more than just formulas and integration. It showed me how Polya's problem-solving method can guide us step by step from identifying what we know to planning, solving, and finally reflecting. I also gained a deeper appreciation for how mathematics connects to real life. For instance, the same methods used here are applied in designing water tank, oil containers, and even architectural structure. Personally, I found that this assignment improved my patience and logical thinking. Sometimes I had to recheck small errors, but that process helped me understand each step more clearly. To me, this experience proved that math is not just about getting the correct answer. It's about developing a systematic way of thinking that can be used in any field. So that's it from my presentation. Thank you for watching.